Good morning and welcome to the University of Arkansas System Division of Agriculture. And we're coming to you live today from the Don Tyson Center for Agricultural Sciences in Fayetteville, Arkansas. My name is Mike Daniels. I'm a professor in the Crop Soils and Environmental Sciences Department. I'm an extension specialist and I co-lead the Arkansas Discovery Farm with my good friend and colleague, Dr. Andrew Sharpley, who you'll be hearing from here in just a minute. But we want to welcome you to our sixth in a series on soil and water conservation. Today we're going to be focusing on our Discovery Farm and our partnership with the Marley Beef and Poultry Farm in Elkins, Arkansas. They're tremendous cooperators and they've been very gracious to allow us to come out and monitor water quality and evaluate conservation practices on their farm. We're also going to hear today from Dr. James McCarty. He's going to be talking about Beaver Water District and the efforts they take to protect drinking water for over 500,000 people in Northwest Arkansas. But without further ado, I want to introduce one of the world's leading scientists in water quality, especially phosphorus and how that interacts with our lakes and streams, Dr. Andrew Sharpley.
Thanks, Mike. Yeah, I'm Andrew Sharpley, and I've been at the University of Arkansas for nigh on 15 years now, which time flies. Anyway, I work in the Crop Soils and Department of Crop Soils and Environmental Sciences, like Mike says, and I'm work off the campus in Fayetteville. And so the Discovery Farms program got started, I'd say probably about 15 years ago in Wisconsin. And we went up there independently to review the program. After it had been going for about 5 years, Mike and I thought that this would be a good program for Arkansas. So we worked with Farm Bureau to take a group of farmers and leaders in Farm Bureau to go up there and talk to their discovery farmers and see what was going on up there. They came back and said, we need this in Arkansas. So Mike and I started banging on doors and asking, to get some support for this program here and in Arkansas. And eventually it bore fruit. And so one of the real reasons behind the Discovery Farm program, it's a on-farm program, and it's really led by farmers for the farmers. And we, Mike and I, kind of manage the program for them. But part of the reason behind doing the program was to the concerns that farmers were having with water quality, and sometimes the finger pointing that was going on without any knowledge behind it. And so we're in the Mississippi River Basin. Most of the water that drains from the US, it's about 41% of the US, drains down to the Mississippi and into the Gulf of Mexico. And it's the third largest watershed in the world. And so there's a lot of things going on there. A lot of people live there, diverse agriculture, huge cities. And so it's very difficult to determine exactly where a lot of these nutrients are coming from. But the Environmental Protection Agency and USGS, US Geological Survey, used a model to try and get an idea of where they were coming from. And based on that model predictions, the Natural Resource Conservation Service identified about 40 watersheds for focusing conservation measures and for earmarking some funds to help farmers implement conservation in those watersheds. And so it transpired that there were about 5 watersheds originally identified in Arkansas, and we really didn't believe why some of those would be the top contributors to nutrients to the Gulf. And so we felt that there was a need for real data from farms, and that's probably the unique aspect of this. It's on-farm work. We're there at the farmer's privilege, and so that it's normal operations of those farms and looking at water quality. And in today's presentation, you'll see about Jeff Marley, and his farm is in the Illinois River Watershed, partly, but mainly most of it is in what we call the Beaver Reservoir Watershed, which is a drinking water source for about 500,000 people now. And so there's a real concern to try and maintain the clarity of water. You'll hear Jeff in a few minutes also say that he wants to present a good impression to the public of what real farming is about. And so, like Mike said, we were able to get funding. We got 4 farms, and you'll see now we've got actually 12 farms. Most of them are in what we call a row crop, which is east and south part of the state. We have 4 farms in the northwest Arkansas where we have more livestock operations, poultry-beef grazing, and 1 dairy. So it's a diverse program. And on those farms, we would go to those farmers, or they would come to us volunteering to be a part of this program. It's not right for everybody. We did approach some farmers to see if they were interested, and they said, no way. If I get into this type of a program, it opens me up. The data will be out there, and the EPA will come and shut me down. And anyway, that was never happened. And one of the farmers that was concerned about that actually has been my most vocal advocate and a discovery farmer down, which was a subject of an earlier virtual field tour. But today we're going to focus on the Marley Farm. And what we tend to do is we would go to the farmer, talk with him, find out what he wants to know more about. The Marley Farm is split between woodland and pastures, where he grazes about 300 head of cattle. And he has 10 poultry houses that have at any one time 230,000 broilers. And so those broilers live there, and they walk around on what we call bedding, pine shavings, sawdust, and so that creates a manure, it creates a fertilizer, and it's a valuable source of nutrients, and that's where it's been synergistic for both the poultry and the beef. It means that farmers have a cheaper source of fertilizer, their pastures grow better, which means they can have more head of cattle on a field than they could before. And so it's a win-win in many ways. However, when you get that many chickens, and there's a lot of other farms in this watershed, sometimes too much of a good thing presents some concerns. And so what Jeff wanted to know was how much nutrients were running off from around his poultry houses. EPA had been doing some spot checking in the Chesapeake Bay, and then decided to do it up here in northwest Arkansas. They didn't find any problems, but certainly farmers thought, well, we need to look at this ourselves and be proactive. And so he wanted to use a grassed waterway. This was his idea. It was a pasture. He wanted to fence the cattle out and see how that field could effectively reduce nutrients from going in to a little creek that runs into the White River, which runs into the Beaver Watershed Lake. And so that's what we started doing, and we put up some equipment there. And so this is the Marleys. It's been a great privilege to be working with them. He has been one of our most, one of the longest discovery farmers we've got. And so we're really happy and proud to have him, and he's going to be a great spokesperson. He's had multiple tours on the farm. And the other thing about Jeff, he's very humble, gives the impression he doesn't understand a lot, but you will be able to see pretty soon that he knows more than he's actually going to give away. And I think Mike and I would both agree that we've learned more about from his operation and from farming and the pressures than he has from us. So we've been great privilege to introduce Jeff, and thanks.
Hi, I'm Jeff Marley. I'm a poultry and cattle producer here in Northwest Arkansas. One of the biggest challenges that we're facing and the pressures we feel is the nutrient containment from our operation. This has gotten a lot of attention in the past. We're in a nutrient surplus area, but I've used the Discovery Farm and their assistance in finding the details of where our nutrient losses are and how we get to manage to keep the nutrients on the farm and not having any surplus get off the farm. We've got abilities to test it and then to see what it is, where it is, and then to try to make sure that we don't become one of those individuals or one of those operational sites to say, hey, we've got an overload here and this is excess, and what are we going to do with it? That's the biggest challenge that we're starting to feel we're faced with, we're being challenged with. And that, I spend most of my time now managing my nutrient management program more than actually managing my livestock operation. I became involved with this Discovery Farm operation after visiting with my extension agent. I was looking to see if my best management practice, my BMPs, were up to the task of maintaining the nutrient loads on my farm and not letting them get caught up and carried off. I'm not too far from the White River, so that was a very high concern of mine. Visiting with him, he said, hey, we've got a program going, and the individuals, when I visited with them, Andrew Sharpley and Mike Daniels, and Johnny Gonzalez was the extension agent at the time, he said, hey, this is what we're looking for, and then it was very parallel to exactly what I was wanting to find. And so far, everything that we have done has been very positive, and it has worked. It's not difficult, and most of it is just implementation and having it set up right. My objectives was to find how to control it. Their objectives was, hey, he's trying to control it. What are the numbers? Because we did not have any real numbers at that time. And they said, hey, we're going kind of off of educated guesses and if we install these monitoring stations on your farm, we will then get real numbers. I did not have real numbers. I had educated ideas. I had educated soil tests and numbers that was projections, but actual having real data right out of the university labs, I did not have, and they were going to provide that. And so we both were hungry for the same numbers and the data and the information. I mean, we were looking for same, and so it was a perfect timing for both of us to get into this part of this Discovery Farm for this nutrient management. After we got the program off and started, then we started getting some data in, we was able to know, we noticed, and the numbers then told us that some of the solutions of the problems that we thought would have had to do, I did not have to do those. I mean, one of those, I'll just as an example, was put in filtration tree strips to gather and hold dust out of our fans. Well, we found out that yes, there was some come out of those fans. We all know that it does, but it did not migrate that far from the buildings. And in the case of the different monitoring stations, like as this one in this pond here, and then we have another one on a 600-700 foot grass filtration strip, was the levels that entered those are set up 80 to 100 feet behind these buildings. We were losing 70 to 80% of nutrient reduction consumed in the pond and also through that grass filtration strip down to levels of, hey, this is real close to what it naturally occurs in these stations. From the front station to the second station was a 3/4 to 80% reduction in nutrient load in the testing. So what that then gave us confidence in saying, hey, if we have the ability to put these practices in and implement them around these locations, then we don't have to go to spending volumes of money of whether we collect it and move that nutrient, put it right immediately in a building or a barn, which is a handling cost, and then move it off farm. We can leave it in the buildings, and then as our annual cleanouts go, that nutrient load can be moved off in those areas that are very nutrient demanding in the crop fields, several hours from our location. A lot of this data and information that we've gotten off working with this Discovery Farm has aided in the programs and practices that we've implemented, which fall right into the conservation practices, the wise use practices of my farm and our industry can implement these. In my particular case, a half a mile off of the farm is the White River. The White River is one of the main supply bodies of Beaver Lake. Beaver Lake is the main water source for 400,000 to 500,000 people in all of northwest Arkansas. Then it goes on to the Table Rock, Bull Shoals, North Fork, and on down the line. So we're right here at the head of the point of the spear, as the saying goes. And so a lot of these practices that we've implemented to judge, are we keeping our nutrients on farm? Do we get to move it into a pond for dilution effect before it leaves our control in our body, before it moves into as the saying, the term that's used, the waters of the U.S., or in the other situation where I have the 700-800 foot grass filter strip, where all this reduces those nutrient levels to where then when they do actually enter into a stream or down, let's just say downstream, then they are down at normal levels that you would experience under any flooding conditions. And so what we have gained in this was these practices that we've implemented, that we have confidence in saying, hey, yes, we are a nutrient-rich spot, but now look at the data, look at the numbers that we have composed, look at the effort that we've exerted to keep that on site, and the effort and the things that we have done to reduce those and get those consumed before it starts moving downstream into those more critical areas, before it moves on down into that Beaver Lake system. I'm just one spot, but if everyone did it, every little one spot adds up. It's back to that camel that breaks, the straw that breaks the camel's back. Every little piece adds up. Flood events are flood events, but this is just daily routines. And so pretty soon the little adds up to more and more until it adds up to the whole. And hey, look, we've really reduced it. In conjunction with operating this farm, I had the opportunity and was invited to serve on a board, a conservation board. It's Beaver Lake Watershed Alliance. We've been designated and given the responsibility through a study of about 30 years ago to maintain the watershed of Beaver Lake, so that the water that flows in there. The individuals that came to me were well aware of what my operation was, and my location was also critical because I was on the river. But they also understood that I was part of the overall watershed in the Aerate community. The Alliance covers, whether it's business, it's the urban development, the business, the headwaters, and the Forest Service, the farm ground, is recreation, is business doing this, and we have about a dozen different areas that we have representatives on the board, and so I was asked to serve on that, and I agreed. It's a voluntary board, and so we've been given the designation and the responsibility to overlook at the watershed that goes into Beaver Lake, whether it's right on the lake or plumb up at the headwaters at the point source as the locations is referred to. I'm probably in the point source area instead of right there on the lake. We work in conjunction with the Corps of Engineers and other, the Forest Service, Game and Fish, and all the other entities that out there. And then there's several other conservation groups that function in our area where we're all very compatible and we all work together. We're all partners, and so we get groups together. We put together informative meetings, whether it's on their forest lands, their pasture lands, and in two particular cases, what we've been instrumental on is like in this farm ground that you might see over my shoulder, there is aerators. We've got one of those that we will provide for individuals to aerate their soil with. What that does is, and most of that's going to be close to river bottoms, close to watersheds, that will let a rapid influx of water into the soil instead of running off. So whatever gathers on top all of a sudden gets into the ground and it gets held. That's one of the main practices that we have facilitated, and we've got the machine to do that. You know, and then, like I say, we have different groups for planning and cleanup sites. We do those. You know, we do cleanups on the rivers. We go out and we look at stream banks and say, hey, yeah, this needs some stabilization. It said, hey, we need to get you with this group, whether it's NRCS or WCRC, Washington County Conservation Group. So I mean, we put that together, and so we have actually became from just a one-person committee. I mean, there's 20 individuals on the board, to where we have 6 or 8 individuals now working for us, and they're spread out, and we get grants to go out and implement these different programs and to monitor and see and get feedback. And as time goes on, individuals come up with more and more ideas, and hey, if it works, we use it. And then so far, you know, our group is growing, and we're getting more and more interest. Of course, the dynamics and the demographics of Northwest Arkansas are expanding at the rate that it is. A group like ours, people are always coming to us, whether it's just for a small rain garden next to a building to keep their erosion down, or is it a bigger location? You know, what am I doing? Well, you know, how am I get rid of these invasive species that are letting the ground erode? And so, you know, it's a vast array and a multitude of things. What I've taken away from this Discovery Farm program is that, hey, this is money well spent. We have got information, true data, true numbers. I've addressed some of this in the past, but that we did not have before, so that we know now what we are talking about. The individuals that come, you know, the support for the Discovery Farm through the finances of the Extension Service has created a very positive image of this. And so, you know, then the conclusion of all this, it was money that's been well spent. It's well managed by with individuals with not an agenda. They have well-intentioned, you know, objectives and goals and clearly stated to us, and we've reached those. And now we're looking at different areas that, hey, maybe we can get information that we don't have relative to this. And so in the end of this is the money and the efforts and the time of the individuals that has been presented and put to this program has been extremely beneficial. Everyone I've talked to has come back and said, wow, we didn't know we had those. We have gathered and accumulated knowledge that we did not have before, and that we can say now, hey, we know this to be the case. Maybe exceptions, but this is still going to be the case. Instead of guesstimations, we actually have real numbers now that we can fall back on and say, hey, somebody asked something, this is what you can expect. I would like to thank all those involved, whether it's the administration, the funders that, you know, that has put this program together to gather all this, and it's all been, you know, everyone has been very helpful, everyone's very agreeable. And one of the biggest offshoots from this, for those that, so you know that your money has been well spent and your efforts have been well, you know, all the ones that have put effort into the Discovery Farm. I will have tour groups on this farm, and never fails to have at least one individual come up and say, hey, I did not know this is the way it was done. So now we've got another advocate for our side. So thank you for supporting this program. I think it's been well worth it. Thank you for watching today. You know, we put our time in, and you're all putting your time in. Thank you very much.
Thank you, Jeff, for that overview of what you're doing. And again, it's been a privilege to work with you. So what I'd like to just quickly follow up on what Jeff has been talking about is just showing a little bit more about what we do. This is a flume that he was standing in front of. When it rains, water collects in there and goes through this little gap here. This little black tube also will get triggered when it senses water going through there and suck water up into these into this kind of equipment box here. You'll see it's run by solar power, and then we also have a rain gauge here to know how much it rains. So this is an automated sampling system, and it's been used widely around the world, and it really revolutionized a lot of what we do in terms of collecting water samples, because before this we'd have to get out there when it rained, often in the middle of the night, and collect a sample. But this will do it for us We just have to get out there that next day within 8 hours and collect the samples. But you can see here water running through this device, and the more water that runs through there, the higher up it goes up here, and that we record that so we can then know how much and how many nutrients have actually run across. And so in that box there, we have one of these samplers. These are automated samplers of water pumped into this bottom container. It's run by solar power, as I say, which charges these marine batteries. We do have a few friendly and sometimes not so friendly lodgers in these samplers, but it's then we analyze it. We get that sample, bring it back to the lab, and here Stormy is getting ready to filter the sample. Then we pass it across the corridor, basically in the Don Tyson Center, and they analyze it for nutrients, fertilizer nutrients like nitrogen and phosphorus, and also how much sediment, soil is in that water. And from that, we can then determine, how effective those practices are. So just a quick overview of what we found at Jeff's farm. This is where that flume we were standing in front of. This is the other flume. And we found that the water flowing from here around the houses, before it gets to our next site down here, there's about a 30% reduction in flow. So water that actually seeps into the ground. And this is the area that Jeff wanted to try out. He prepared the area. And these are just the averages over a year to annual losses, just over the 6-7 years that we've been monitoring. So this is the total average of that period. The red is what's coming off and getting into that first flume, and this is after it's been through. The green is after it's been through the grass waterway. You can see that we're getting quite a large reduction in nutrients. It's being retained in that pasture, it's been fertilizing that pasture. This conservation measure that Jeff wanted to try is working. This is how much gets into that pond. The red is what comes off the house that enters the pond. This is what's in the blue is what is in the pond. Again, you can see that pond retains a lot of nutrients, and those nutrients he uses as irrigation at times, and also for drinking water for the cattle around the farm. So this is really another way of him recycling some of those nutrients back onto the farm and becoming more sustainable and really making the most value of what he's got out there. And so with that, I'd like to introduce James McCarty, who works with the Beaver Water District, and he's their environmental quality manager. And this, the reason that James has graciously taken the time to be with us today is that this is the whole cycle of where that water goes and how important what Jeff is doing. But before I let James get on here, I just want to remember that that if you have any questions, please put them in the Q&A box at the bottom, and we'll do our best to answer them. Maybe we can't answer them all, but we'll certainly give it a shot. So please use that. Anything that you think of is really welcome. So with that, James, thank you.
All right, thank you very much, Dr. Sharpley, for that kind introduction. As he said, I am James McCarty, and I work for Beaver Water District, the water utility in Northwest Arkansas. And we serve roughly 350,000 customers from our utility, and the remaining utilities on the lake actually serve a total of about 500,000 people in Northwest Arkansas. That's 1 in 6 Arkansans that are getting their drinking water from Beaver Lake. And so if I can, let me share with you all just a brief presentation that kind of talks about what we do at Beaver Water District and also how that applies to the Discovery Farms and the research that they're doing there. Sorry about that, technical difficulties.
While we're waiting on this is Mike Daniels. I want to mention that we have a very strong partner in all this Discovery Farm program, and that's the USDA Natural Resources Conservation Service. You'll hear throughout from all of our speakers the role that they have played in helping fund and with technical assistance in what we're doing. on our discovery farms. And so we'll talk a little bit more about that, but I do want to acknowledge these webinar series, live virtual field trips that we're bringing to you would not be possible without their participation and generous funding toward this effort.
Okay, let's try this again. Can you see my screen now? I'm getting the thumbs up. That's great. Okay, so briefly, I'm going to talk to you about how we treat water and where our water comes from in Northwest Arkansas, which is Beaver Lake, what we're doing to protect the source of our water, and some about the water quality as well. So for just a brief overview of our water treatment process, we pump our water out of Beaver Lake from an intake structure on the lake up to our plant, where it goes to what's called a flow splitter box. And that splitter box essentially just divides the flow between 3 separate treatment plants. Now we have 3 separate treatment plants. They all function essentially the same and perform the same set of tasks. But as you can imagine, when you want to expand because the population in the area is growing, a lot of times you can't just pump more water through a plant. You have to build a completely new one. And so that's why we have 3 separate treatment trains that all function essentially the same. Now from the splitter box, it goes to what's called the flocculation sedimentation basin. And within the first structure there, we're adding chemicals that are helping the sediment in the water to bind together and form larger particles. And then in the second structure here, the sedimentation basin, we're counting on those heavy particles that have kind of bound together to sink to the bottom and form this layer of sludge. So then what happens is the clean water actually overflows the top here, where it goes through what's called a lime box, where lime is added to adjust for pH. And then finally it goes into a filtration system where we add chlorine on top, and that disinfects the water. And then it flows through a mixed aggregate filter media that consists of a coal byproduct called anthracite, sand, and 1 or 2 other things as well. Once it goes through the filtration, which polishes the water and removes any little bit of turbidity or cloudiness of the water, it goes into what's called our clear well, which is essentially our storage where we pump our water to our different customers. So at Beaver Water District, we are a wholesaler of drinking water, which means that we essentially have 4 customers: the cities of Fayetteville, Springdale, Rogers, and Bentonville. And each of those cities then in turn wholesales out to other cities as well. For example, Fayetteville sells water to Wheeler and to Farmington and Elkins, but they also sell water to retail to individual customers, like residential, commercial, and industrial customers, which is why those customers will have potentially City of Springdale or City of Fayetteville on their water bill and not Beaver Water District. It's because we're wholesaling our water to them. Where our water comes from, as I said before, it's from the Beaver Lake and Beaver Lake Watershed. Beaver Lake is a U.S. Army Corps of Engineers lake that was impounded in 1966 when it started to fill. It's been authorized for flood control all along the White River system, power generation, as well as drinking water supply. The watershed is roughly 1,200 square miles and has a land use of around 60% forest, 27% pasture, and 6% urban. And as I said, it's a water supply for 1 in 6 Arkansans. If you look at the map that's shown on the right-hand side of the screen, just for reference, we've got our different cities here: Fayetteville, Springdale, Rogers, and Bentonville. And just to the east of that is the entire Beaver Lake watershed. So we have the lake up here in the northern part, and then this entire southern area is the watershed that drains to the lake. And if you look, here is Elkins, and this is actually where Jeff Marley's farm is located, in his discovery farm. So safe drinking water starts at the source. And I've included an image on this slide here that shows it's actually Lake Erie in the northern parts of the United States. And this green business on this lake is what's called cyanobacteria. It's a type of algae. And it can bloom, and a lot of times these blooms can be seen from space. And let me tell you, that's not a good thing. Back in 2014, the city of Toledo, which is kind of down here in the southwest corner of the image, they actually had to shut down their drinking water treatment plant for a period of 4 days because the cyanobacteria bloom started producing toxins. And those toxins were deemed harmful to human health. And so for a period of 4 days, they had to figure out how to treat their water to remove these toxins. And a city of hundreds of thousands of people essentially had to drink bottled water. As you can imagine, this is not a good thing. But this is what's called a harmful algal bloom, and is a result of sediments and nutrients that end up in these water supplies. We also are concerned about pathogens and the level of pathogens that come into our plant. All of those have to be disinfected, and so obviously the less there are, the safer our margins in producing drinking water. And then sediment and organics are definitely a concern for us because they can have a direct impact on the amount of algae that's produced, but also in the formation of things called disinfection byproducts. And these disinfection byproducts also can have health consequences if their levels are too high. So the main thing that we are really concerned with and that we try to control is algal growth. And algae, just like your backyard tomato plant, because it is a plant itself, needs nutrients, it needs the right temperature and sunlight conditions and the right water conditions as well. And so hydrology and water chemistry within the reservoir are important things in determining how well algae will grow. When you're thinking about, okay, how do we reduce the amount or contain the amount of algae that grows in a lake, the most cost-effective thing to control here is probably going to be the amount of nutrients that enter that water body. And so where do our nutrients come from? Well, they come from a lot of different places. Urban areas, residential, industrial, commercial. But since we're talking about discovery farms here, and this is an agricultural presentation, we'll just talk about it in terms of agriculture. And so Jeff really eloquently put it, and then Dr. Sharpley kind of followed up with his examination of those flumes and the runoff that goes over the fields. Nutrients are definitely carried in runoff from agriculture. And the Discovery Farm has been excellent in documenting how some of these best management practices like grass filter strips and overland flow can reduce, as we've seen in the Discovery Farm, the amount of phosphorus and nitrogen that are ending up in waters of the United States. The concentration of nutrients in agriculture tends to be higher because there is the application of nutrients to help plants grow, but also the application of litters and manures that contain those nutrients. And then we have issues of legacy loading. So loading is a term that's used to describe the amount or mass of nutrients or sediment that enters a water body. So when you're thinking about legacy, that's going to be stuff that's been deposited down over potentially generations. And that stuff has the tendency to slowly leak back into a water body. And then once those nutrients and sediments actually get to the reservoir, in this case Beaver Lake, we have this issue of nutrient cycling where algae potentially use nutrients within the lake, they die, they settle back to the bottom, and then those nutrients can come back out again to be used by algae again, over and over again, this cycle, before those nutrients finally leave the reservoir, sometimes maybe even years or decades later. So what are we doing at Beaver Water District to try to combat this problem of sediment and nutrient transport to Beaver Lake? Ultimately, to try to reduce or limit the amount of algal growth that affects our drinking water treatment operations. Well, first, we have a pretty robust education and outreach program where we are talking to people about the contaminants that end up in Beaver Lake and what they can do to try to prevent those things. We do quite a bit of research in-house and through different partners, including University of Arkansas Extension and University of Arkansas researchers. We help fund and participate in stream restoration and bank stabilization efforts. Bank stabilization efforts within a lot of times the riparian zone, which is the roughly 50 to 200 feet on either side of the stream. We also engage with agriculture, commercial, and residential interests and stakeholders to try to implement best management practices. And that's really where this Discovery Farm kind of drinking water partnership comes into play. We are heavily invested in the agricultural community to try to encourage the use of these best practices that have been researched and vetted through the Arkansas Discovery Farms program. In-house, we also do controlled burns that helps reduce the amount of organics that flow into the lake, and also helps to infiltrate more water so we have less runoff over our land. We work with the Northwest Arkansas Land Trust to help acquire or purchase conservation easements, and those help preserve some of the lands with the best environmental benefit out there within the watershed. And then we do a lot of stream and lake water quality sampling in-house. During the summer, we're probably out on that lake or in the watershed at least 2 to 3 times a week, collecting samples. And those samples give us an idea of the condition of the water body and also trend analysis to see maybe which streams or areas of the lake are improving or getting worse or staying the same. But I've actually got a little video to share with you that kind of highlights some of our efforts. It's a really short clip that shows just us out on the lake and our sampling efforts.
Did you know the Beaver Water District protects the public health by monitoring water quality within the lake on a weekly and sometimes even daily basis? For a snapshot in time like today, what sort of things are in the water? Is there a lot of nutrients? Is there a lot of algae? We call those things contaminants, and they can potentially affect how we treat the water and deliver that water to you. Long term, over the course of a summer, even over the course of years, we want to see how the lake is changing over time. Each of these sites may be impacted by things going on inside the lake, things going on inside the watershed, land use of the watershed. All of those things are going to have an impact on water quality. And when we look at that data, we bring it back to the lab and start to analyze it. Is there potential for these contaminants to reach the intake? And if it reached the intake, what sort of changes in our treatment strategy or treatment technologies would we need? And would there be any impacts on the quality of the water? The bottom line is we're always going to continue to deliver clean, safe drinking water.
So that's really our goal, is to deliver clean, safe drinking water, but there's a lot that goes into that process to make sure that our source water is good and continues to be good for the foreseeable future, and to make sure that we're providing the best water treatment and safest water to our customers. So one of the ways that we do that and accomplish all this stuff is through source water protection funding. And in 2016, our board adopted to allocate 4 cents on every 1,000 gallons that we sell to a source water protection fund, which results in about $850,000 a year right now that goes exclusively towards source water protection activities. Now, these can be stream restorations, conservation easements, support to our partners like the Beaver Watershed Alliance. And this funding is great because it's proportionate to water use, which means that an industry that maybe uses a lot of water ends up contributing more towards source water protection than maybe a residential user that doesn't use as much water. But our board has been very supportive of these efforts, highlighted by the late John Lewis, who was a past BWD board president. He said it's about building something sustainable where water can always be taken out of the lake for drinking. We want to preserve the water quality of that lake for future generations because it is such an economic engine for this region. So the main way we do that is really just through working together in cooperation with partners. Our main partner is the Beaver Watershed Alliance, and we provide them with extensive funding to go out and engage stakeholders within the watershed. This means landowners, residential, commercial, agricultural producers, and they're tasked with education, but also in finding ways to reduce the amount of sediment and nutrients that are transported to the lake. We also always try to find alignment of mutual interests, which means that we don't really exclude any partner. If we can find some common ground and some things that we can work on together, then we're going to work with you. We believe strongly in agricultural land stewardship. which is why we promote so many programs and have funded a lot of these programs to implement best management practices on agricultural lands. And one great example of that is through the Regional Conservation Partnership Program, or RCPP, which is a program that we've started here in Northwest Arkansas through the NRCS. Now, our RCPP is for the West Fork of White River, which is one of the main tributaries to Beaver Lake. And it's roughly an $8.6 million funding mechanism, half of it funded through NRCS and the other half funded through partners like the district, which hopes to achieve, we're in year 4 or 5, and so we're coming close to the end, but hopes to achieve 1 to 2 miles of river restoration on the West Fork White River, 2 to 4 miles of riparian restoration, so those are the areas on either side of the stream, and a very large 80% decrease in the amount of sediment and nutrients that are transported from the West Fork to Beaver Lake. And we're doing that through this RCPP funding mechanism, which includes Environmental Quality Incentives Program through NRCS of roughly $2.2 million. And that's money that's going directly to agricultural producers for best management practices. Then there's PL 566, which is a funding mechanism that was originally intended for large watershed improvement projects. And we are using it for stream restoration on the West Fork with roughly $6 million. Then we have some additional funding in monitoring and education. But for us, the big win was that we were able to leverage roughly $1 million on our part in contributions to achieve this $8.6 million RCPP project, which is an 8-to-1 leverage, which is exactly what we are hoping to do with our source water protection funding is leverage large amounts of money to bring into the watershed and help agricultural producers as well as residential, commercial, and industrial interests as well. All of these with the goal to reduce the amount of nutrient and sediments that are transported to the lake and help maintain the water quality of that lake for future generations. And with that, I'm going to turn it back over to Dr. Sharpley. And I just want to thank you all for the opportunity to share a little bit about what the district is doing in Beaver Lake. And also just want to highlight again how important this Discovery Farms program has been to us in helping to research and vet a lot of these practices that are being used today by producers in the entire region.
Thank you very much, James. That's really good. You were eloquently just parceled everything up as to why it's important to protect our water. And we really appreciate the time you've taken to be with us today. So I just want to kind of wrap up quickly so that it gives you time to still put some questions down in the Q&A and then Mike can answer them all, I hope. Anyway, I just want to get a bit more idea of the program, just the basic big picture, 20,000 foot, whatever you want to call it, 30,000 foot view of it. It's more than just collecting data. It's facilitating farmers to be proactive. Rather than being told what to do when the researchers come in, they are part of it, and that's a critical part of this whole process. And I think this is where the Discovery Farm has really been important across the US and other similar programs, that we're engaging the farmers to be part of the solutions that might come on their own property. I think there's at least in Arkansas, we have great collaborations with Farm Bureau and the farmers, and and Farm Bureau have been very proactive in engaging farmers rather than ignoring this and burying their heads in the sand that we don't have a problem. They recognize that they'd rather be a part of the process, and it's also involving them in the solutions. And I think one of the big things, Mike and I have talked to many different groups, state legislatures, but farmers carry more, I hate to say it, Mike, but they carry more credibility than we do. And so farmer-to-farmer education is a real product of this. The farmers listen to other farmers. They also watch what others are doing, and they may not adapt everything that Jeff's done, but if they adapt a little bit of it, then that's a win for everybody. And if they see what Jeff's doing is working and it works for him, they're more liable to be engaged in the conservation process. So this is critical, and it's a real fundamental part now, I think, of outreach and extension in Arkansas. It also educates policy makers and the people that, like Jeff says, come onto the farm and say, I never knew this, and this is what happened. I thought that such and such. It's not what people think. And that is really important, educating policymakers, educating the general public to what farming is, that, where the food that they assume comes from the supermarket actually comes from what is put into that to get it into the, on their table from field to fork. So it's engaging that other sector. But I think one of the things that we found is really important to this whole process is the engagement and the involvement of the farmers. It's not for everybody. Some of them shy away from, the public. I just want to get on with work. That's fine. We respect that. But they still part of the program. But the others that want to show what they're doing. And so it's involvement. But I think the critical part here is empowerment. And we're empowering farmers to be a part of that change and a part of that process. So with that, I will let Mike take over. Thank you.
Thank you, Andrew. First,
put yourself on mute.
Okay. Thank you, Andrew. I want to thank all of our speakers today. Andrew, James McCarty, and most of all, Jeff Marley, who's taken time out of his busy schedule to join us today. And it's not just Jeff. When you work with Jeff, you're going to work with all the Marleys, Marsha, their children, just a great family. And we're so appreciative of the effort that they make to accommodate us. I also want to thank NRCS. They are providing the funding through a grant to Dr. Julie Robinson, who's the PI on the grant, to produce these virtual real-time field trips for us. And I think one theme you heard throughout these speakers is the fact that NRCS provides funding in a lot of different mechanisms. First of all, they fund a lot of our discovery farms through EQIP, and that's through Conservation Activity 201 and 202. And we're lucky today that in attendance, we've had Karma Anderson, who oversees that program nationally for NRCS. And then we also have Roger Cousins, our state water quality specialist, who oversees the program in Arkansas. But we do a lot of edge of field monitoring through Conservation Activity and Conservation Activity 201 and 202. Secondly, you saw that they do a lot of cost sharing with farmers, but then they also do grants to help us look at specific items related to soil and water conservation. But the third thing they do is they provide funding for what you saw that the Beaver Lake Water District is doing is the Resource Conservation Partnership Program. So they are a very big part of all of our efforts here in Arkansas and trying to protect our natural resources. We've got some questions, and the first one that we have, Andrew, is for you. It is the question about how economical is it to lower the nutrient levels on these farms?
Thanks, Mike. That's a good question, and it's one that everybody, I guess, is fundamental in the back of their mind. It's not easy economically. It probably isn't economically that costly. It just takes time. You can grow crops or you could grow pasture, then you cut that hay, you remove those nutrients, and slowly you take it down. So you can reduce it that way. There really isn't, especially for phosphorus, once the nutrients are pretty high in soil, there's not, you can add things, but then you run into problems of what you're going to add. Is that going to create another problem? So my guess, my best answer is it's not that expensive to reduce it, but it takes time. And so the best option is to avoid it getting high in the first place, to reduce those nutrients in the soil, and the same in the lake. So I think the cheapest way, most cost-effective way, would be to stop or reduce those increases from the get-go.
Thank you, Andrew. This next question is for James. Has Beaver Lake ever had an algal bloom? And the follow-up is that, what is the current condition of Beaver Lake nutrient-wise? So has it ever had an algal bloom, and what's the current condition?
Yeah, so most water bodies are going to experience an algal bloom at some point, and Beaver Lake certainly has had a fair share of them. But I think maybe what the questioner is asking really is a harmful algal bloom, and there's a big difference there. Algal blooms happen all the time, whereas harmful ones are going to be ones that are going to adversely affect either aquatic or human health. And as of right now, we have not experienced a harmful.
Well, it seems that we've lost the audio from James. I think he froze up. If he gets back on, we'll go ahead, James.
We consider it adequate for drinking water treatment, which is why our goal really is to maintain the water quality.
Okay, thank you, James. I've got another question for Andrew. Is the pond considered a conservation practice? And if so, how does it function?
It is. It functions by collecting water that would otherwise go into a creek or leave that farm. So it also, you could use it to reduce erosion. So it is considered a BMP. I think its main function would be as a water collection for cattle, for drinking water source, or irrigation to reuse that water. I think a secondary benefit might be that it would trap nutrients like it does on Jeff's. But I think the main benefits and what NRCS would adopt would be to collect water that would be a drinking water source, and also reduce water running off. Thanks, Mike.
Yes. Andrew and James, this question is for both of you because I think you bring a different perspective on it. But the question is, are nutrients really considered a contaminant? And maybe saying excess nutrients would be more accurate. Can both of y'all address that?
James,
go ahead. Yeah, I'll go first. Not technically considered a contaminant. Contaminant would probably be more like a chemical or an oil or a hydrocarbon or something like that. But for our purposes, we kind of lump excess nutrients, which is probably the more accurate way to say that, in with other contaminants or things that are going to cause concerns for us in drinking water treatment.
Okay, thank you.
Yeah, I mean, I would add that you're right. It is excess nutrients would be a better term. It's not a contaminant, like James says. It's a fine line, and it's a fine balance between algae provide a ecosystem in waters, rivers, lakes, whatever, as a source often of food for the fish. And so it's just like anything else on the land. You need some nutrients for those to grow, to have a healthy aquatic environment. But if there becomes an excess of nutrients, then those algae can keep growing. And as James alluded to, they're going to have harmful algal blooms, but you could also those algae will, like plants, use oxygen, and so they can deplete the oxygen in the water, a bit like the Gulf of Mexico, which has got a hypoxic zone. So it is a balance, and I think we have to remember that having some nutrients in waters is beneficial for having a what we would call an ideal ecosystem. It's just when they get above certain thresholds, which EPA have defined, that we run into some detrimental uses which would impair the use of that water would be in case of beaver, it's for drinking water.
Thanks, Andrew. We want to thank you again for joining us today. We're going to have to wrap it up. If you do have questions that were unanswered, you can always email myself or Andrew. My email is mdaniels@uaex.edu. We also encourage you to visit our webpage, www.uaex.edu, to get more information. Apologize we couldn't get to all the questions, but our time is up. But again, thank you for taking the time out of your busy schedules to learn more about protecting source water in Beaver Lake. Thank you.
Thank you for joining us for the Soil and Water Conservation Virtual Field Trip. This broadcast is funded by NRCS and produced by the University of Arkansas System Division of Agriculture Cooperative Extension Service. To find out more about soil and water conservation, visit uaex.edu.